Hello everyone, welcome to this session. In this session, we are going to study one topic in the axially loaded column and eccentrically loaded column, unit number 6. The topic is Rankine's formula. In the earlier sessions, we have studied the Euler's theory, but that Euler's theory is only useful for the long columns, which is subjected to or which is failed due to bending stresses or buckling stresses. So that theory we have studied last time, it is only for the long columns. So already you know that how to determine the critical load on which the column will fail. That critical load, it is called as the Euler's critical load, and symbolically it is represented by P suffix capital E. So that E is nothing but the Euler's, right? So that Euler's theory, it is also very important for the long column. But there are some limitations are there, which is we have seen in the Euler's theory. That theory or that formula we cannot use directly for the other type of the column, because already we know that there are three types of the columns, that is a short column, medium column and long columns. So we cannot directly determine the critical load on which the column will fail by the Euler's theory. Okay, so in this particular theory we will study that formula which is developed by the Rankines. So Rankine is the one of the scientists who has developed one empirical relation which is useful for all the type of the column. Means it is useful for short column, medium column and also long column. Okay, so this Rankine's theory or Rankine's formula we will see in this particular lecture. Okay, let us start with this video. So first of all, Rankine's formula. To eliminate the limitations found in Euler's theory, Rankine developed an empirical relation which gives corrected result for all columns between short to long column range. This Rankine development relations or empirical relation which is used for all the type of the columns, right, from the short to long range. So here it is one empirical relation which is given by the Rankines. It is written or developed by Rankine is 1 upon P is equal to 1 upon PC plus 1 upon PE. So what its symbols are stands. This capital P is nothing but the critical load by the Rankine's formula. PC, this PC is nothing but the crushing load. P is nothing but the load, and C it is used for the crushing, that's why it is a crushing load. And PE, so that we already knows that PE is the Euler's critical load. So PC crushing load, it is determined by sigma C into A. This sigma C is the ultimate crushing stress and capital A is the cross sectional area of column, and this P crippling load by the Euler's formula. So this formula here, it is already we have seen or derived this relation to determine the critical load for the long column, or it is also called as the Euler's critical load. So PE is equal to pi square EI divided by LE square. So all these symbols already we know. E is used for modulus of elasticity, I is the moment of inertia, and this LE is the effective length. So already for different end conditions of the column, relationship between the effective length and the actual length of the column. So depending upon the end condition, we can determine the effective length by using the relations, right? Next, this formula or this empirical relation which is given by the Rankines, it is derived here, and you can see how it is simplified this relation. So furthermore, PE plus PC divided by PE into PCS. Sometimes in the different books the PCS is also used because this is the crushing load, we can say. So PC or PCS is one and the same, so you can use only PC, which is the crushing load. So PE is equal to PE, P is equal to PE into PC divided by PE plus PC. If you divide numerator and denominator by Euler's critical load, that is a PE, so then further it is simplified, PC divided by 1 plus PC divided by PE. And already we knows that PC is equal to sigma C into A. You can put the value of PC here in the numerator, and also you can put that Euler's critical load formula that is already at pi square EI divided by LE square. If you further divide, and also you have to put the I, that is the moment of inertia relation, is equal to AK square. So this relation, from where it is come? It is coming from radius of gyration. That is, the formula K is equal to under root of I minimum divided by A. So that is the radius of gyration, and means we'll get that I is equal to AK square. So instead of this formula I, you have to put the AK square. So this is a total relation. You have to again simplify it further, and we have to come up with the relation that finally you can see this P is equal to sigma C. Here it is cross section area will get cancelled, and only one area is remaining in the numerator. P is equal to sigma C into A, and 1 plus small a under into bracket LE divided by K bracket square, right? So this is the constant which is shown by small a. So this LE effective length K is the radius of gyration whose square, it is taken in the denominator, and this total formula of P, it is called as Rankine's formula, or it is a Rankine's crippling load. Okay, and this formula is used for all the type of the column: short column, medium column, and long column. That you have to remember. If it is in the problem, they ask about that column. In that case, you have to determine, or you can use this Rankine's theory to determine the critical load, right? Next one, the constant. So in the formula of Rankine's, there is a one constant it is given, that is A, and this A, you have to remember that this constant term, or the formula of this constant to determine this sigma C divided by pi square E. So this is a Rankine's constant. So you have to remember, if in the problem they ask about determine the Rankine's constant, so you can use this relation sigma C. This is the crushing ultimate crushing stress. E is a modulus of elasticity, or Young's modulus. So this is a Rankine's constant you can determine by using this relation, right? Then LE, already you know that effective length. So many of the times in the problem, effective length are not directly it is given in the problem. It is given the actual length. So you have to convert actual length into the effective length by using the appropriate relation of the different end conditions. If the two ends are fixed, one end is fixed, other end is free, one end is hinge, other end is free. So there different conditions are there, end conditions. So depending upon end condition, it is very important to determine the effective length and the actual length relationship, right? So if you are directly using the actual length, your answer may getting wrong. So better way, you have to use the appropriate relation depending upon the end condition, and then you can put the effective length value. So here sigma C is a crushing strength, capital A is the cross section area, and here safe load. So apart from the critical load of the column, or we can say the Rankine's critical load of the column, so sometimes in the problem they also ask about the safe load, right? So safe load formula, this formula is already we have studied, or we have used to solve the numericals in the Euler's theory. Safe load is the critical load divided by factor of safety. So this critical load is nothing but the Rankine's critical load, which we have derived the formula, and we can determine the critical load by using the relation. And this factor of safety, many of the times it is given in the problem. If they ask about the safe load, means in the problem definitely they will give the factor of safety. So you can use this relation to determine the safe load, the load at which the column will bear without before the failure. So that safe load, many of the times for the design of the column, the safe load is very important for the design, right? So safe load formula is there. And second important note or point is the Rankine's constant is a property of the material of the column, right? This Rankine constant is nothing but it shows the properties of material of the column, which materials, or what type of material is there which is used for the construction of the column. So that it shows with the Rankine's constant. So below in the table you can see Rankine's constant for various materials. These are the most commonly materials used for the construction or any construction of any structures. So these materials frequently we have to use. So that's why we have to remember this Rankine's constant, and also their related crushing stress values are also given. So first of all, the mild steel material, whose crushing stress is 320 in the MPa megapascal, and Rankine's constant, the formula it is given, so that's A, small a, the Rankine's constant for mild steel is 1 divided by 7500. Second, cast iron material is there, whose crushing stress is somewhat larger, or strength is somewhat larger than the other type of the material. The value is 550 crushing stress megapascal, and Rankine's constant value is 1 by 1600. Third one is the wrought iron. The wrought iron crushing stress value is 250, and whose Rankine's constant is 1 by 9000. And last, timber material is also used sometimes in the structures or construction. So the timber material crushing stress is much lower than these other materials. So whose value is 50 megapascal, and whose Rankine's constant value is 1 by 750. So these are the some crushing stress value, and also Rankine's constant value for different materials which is used for the civil engineering construction. So I hope you understood this Rankine's theory and the related terms uh, which is used for the column. So here it is, you have to remember this critical load, because this formula many of the times in the competitive examination also the critical load they ask, and you should know this critical load formula, that is the Rankine's critical load, and the related terms are also there. So in this particular formula, there is the ultimate crushing stress is there is a cross section area of column is required, there is a effective length is required, and the radius of gyration is also required. So radius of gyration with formula we know that under root of I minimum divided by capital A, that is area of cross section. So if you know all these terms, or many of times some terms are given in the problem, so you can find the crippling load for the Rankines, or Rankine's crippling load for the column. Okay, and also one more important thing, this Rankine's critical load formula is useful for all the type of the column. So we have to overcome the formula, overcome the limitations from the Euler's theory that only long columns or large column. So this Rankine's formula, or this particular relation empirical formula, is used for the all the type of the column, that is long column, short column, and the medium column also. That this is the speciality of the Rankine's theory or Rankine's empirical relation. So I hope you understood, and if you have to remember this formula for solving some of the numericals problem which is asked in the exam. So that problems or numericals are based on the Rankine's empirical relation. Thank you very much for attending this class.